Hey, structural geologists. The purpose of this video is to give you some ideas on how you can approach the problem that I've given you, that you're going to be looking at a tectonic region and trying to predict what it will look like at some time in the future. And I suggested you look at 10 million years in the future. Some of you may choose a longer time span to jump forward to. This will challenge you to both do some vector analyses of the plate motions and to try to figure out a way that you can graphically present that. And that will mean like taking a map and somehow fragmenting it and moving a portion of that map relative to another portion. So thought I'd give you some ideas on how you might approach that. So if I were looking at this particular region here, this is the Gulf of California here. We've got mainland Mexico over here to the east and the Baja Peninsula of Mexico here towards the west. And the Baja Peninsula is moving towards the northwest relative to the rest of North America. This is the plate boundary coming up through here. So the green segments are transform plate boundaries, and those are long sections separating these short sections of divergent plate boundaries, which are mostly oriented northeast to the southwest. And to study this, I just chose some arbitrary points on the map, and I'm going to pin those and keep track of where they are. So this is an image obviously from Google Earth. I've imported it into PowerPoint, which is going to work out pretty well for me, and I'm going to show you how I can fragment this image moving forward. So I've identified a couple points. I just chose these arbitrarily on different plates. I called this one Baja 1 over here at this push pin, and then mainland 1 over here for mainland Mexico. And what I want to do is predict how those points are going to diverge from each other over the course of 10 million years. So we ought to see the Baja Peninsula moving to the northwest relative to the rest of mainland Mexico over here. So the first thing I had to do was to figure out the relative plate motions. And from these 2 points, I figured out the latitude and longitude, plugged those into my plate motion calculator, and I set for that, my frame of reference was the no net rotation. So I'm looking for the absolute plate velocities of these 2 points. And here's what I got. Here's my vector analysis. So this first vector here, this is my origin right here. So this would be 0, no net rotation. My first vector is the motion of the Baja 1, that point, and the calculator showed that that was moving 5.24 centimeters per year in an azimuth of 296 degrees, so towards the northwest. So here's that vector. So that is the movement of Baja 1 point. And then mainland 1 point, which was directly east of that on the mainland, that is moving at 1.42 centimeters per year in an azimuth of 221 degrees. So here's the vector for that. That means now that my movement of Baja 1 relative to mainland 1 is 5.1 centimeters. So this line here, this vector here, is 5.1 centimeters long, because I set my scale here as 1 centimeter per 1 centimeter equals a vector of a centimeter per year. So this vector here is 5.1 centimeters long, or that's going to be 5.1 centimeters per year is the velocity represented by that vector, and it's plotted in a direction of 313 degrees, so towards the northwest there. So there is my motion of the Baja relative to the mainland of those 2 points, 5.1 centimeters per year in a direction of 313. So then I went back to my map and I said, okay, what would that distance be in 10 million years? Well, here are my calculations for it. So 5.1 centimeters per year towards 313 degrees azimuth. So I took 10 million years here, 10 times 10 to the 6, and that's moving at 5.1 centimeters per year. That was the length of my vector over here. And I wanted to figure out what is it going to be my distance that it moves in units of kilometers. So I had to divide by 100 centimeters per meter and 1,000 meters per kilometer, and it ended up with 510 kilometers. Again, it's still moving towards an azimuth of 313. So now I went back, and this yellow line here is that distance that I had calculated. That yellow line is 510 kilometers. That's what I came up with here. That's 510 kilometers. I had to figure out on this image what 510 kilometers is. Notice I've got a scale bar down here, so I just figured out the length of that scale bar. I used PowerPoint to figure out the length of that line, and that gave me a conversion that I could use, and then I was able to plot a line that was that would represent 510 kilometers distance, and that's going to be the amount of movement over 10 million years. And again, this line is oriented at an azimuth of 313 degrees. So I rotated that line 313 degrees. So this point here, which is Baja 1, after 10 million years, that point's going to be up here. Now I have to figure out a way to show that. Now, if you want to cut out, print this out on a piece of paper and cut it out and actually physically move it and then reproduce that, you can do that as well. There is a feature on PowerPoint that you can fragment your image and move it with respect to each other. And that's what I'm going to do next. That's going to be my second video. I'm going to put these into 2 short videos just to make it easier to navigate your way through. So this ends the first video. The second one, I'm going to come back and show you how to fragment your PowerPoint image.